In this video, we're going to do some guided exam question practice on the various questions that have come up over the years on deducing or finding the empirical formula. It usually comes up in the short questions, question 4, and as you can see here, it's quite a common question. I found 5 there, just having a quick look. So we're going to go through all 5 in this question. They're short questions, budget 4 to 5 minutes for each one. So this video might go on for 20 minutes or so. So we've done this in class. Hopefully you'll be able to do a lot of this on your own. We're just going to have a look at this one here. First of all, is from 2018. It says epoxy ethane is used to manufacture car antifreeze. That's just a blurb, doesn't really matter. It says it's composed of, okay, and we're given percentages here. So we're given the percentages to help us try and find from the percentages the empirical formula. Okay. All right. So it says, yeah, find the empirical formula of epoxy ethane. So if you know what to do, I'm going to get you to go to the side here. I'm going to get you to pause and go ahead and have a go at this if you already know what to do. All right, so hopefully you've had a go at it. If not, then we'll help you maybe get started. The first thing we should do is write down which elements are here. So obviously our elements are carbon, hydrogen, and oxygen. And what we want to find is the ratio of these things in the empirical formula. So we start by writing down carbon is to hydrogen is to oxygen. We want to know what's the ratio of these 3 things. Okay, so the first thing that you want to do is figure out the percentage of each one. Write down the percentage. Okay. All right, so pause the video and do that now from the question. There they are. All right, so what you should have written here was you should have written carbon was 54.5%. Nitrogen was 9.1% and oxygen 36.5%. And 36.4% is actually what it says in the question. So yeah, that's it. The next thing we want to find is what's the ratio of these in moles? What's the moles ratio of carbon to hydrogen to oxygen? So we've got to get to moles. Now, if you know how to do this, pause the video and work it out. If you don't know how to do this, what we need to do is we need to take the MR of each one and divide the percentage by the MR, and that'll give you the moles. So again, another chance if you haven't done this already, pause the video and do that now. Okay, so to get moles, what we've got to do is we've got to find the MR of each one. The MR of carbon, if you go to the periodic table, you're going to find that it's 12. The MR of hydrogen is 1, MR of oxygen is 16. What we do is we take our percentage in each case and we divide by the MR, and that will give us moles. So when we do that for the first one, that there is going to give us 4.54. So the 4.54 moles of carbon is to 9.1 moles of the hydrogen is to 2.275 moles of the oxygen. Right, the next thing we're going to do is convert this into the simplest or the lowest whole number ratio of these 3 things to each other. If you know how to do that, pause the video and do it now. Okay, if you don't know how to do this, here's a hint. What we're going to do is take the numbers and divide by the smallest one of the numbers. Okay, so hopefully that's triggered a few people. You can pause the video and have a go at this. If you're still stuck, what do I mean by this? It's important that you watch this because it's going to be the same for all of these questions, and you're going to get less help in the next ones. So the smallest is this one, 2.275 is the smallest. So we take that and divide it by itself. And then we divide all the other numbers by that same smallest number, this one here. So 2.275 and divide by 2.275. And then you do each of these. So each of these sums. What you're going to get here is you're going to get 2. This is going to come out to 4. And this one's going to come out to 1. So this is our lowest whole number ratio of carbon to hydrogen to oxygen. 2 is to 4 is to 1. The last thing we're going to do is write down and box the empirical formula. Do that now. Pause the video. Okay, so you should have seen that there's 2 carbons. So we write that like this, C2. There are 4 hydrogens, H4, and there is 1 O. So we're just O1, and we box. Show that's our final answer. That's it. That's that one done. Pretty straightforward, pretty simple, I hope. Right, that was 2018. 2015, this one came up. It says when 19.05 grams, so this time we're given grams, of copper reacted with nitrogen, 20.4 grams of copper nitride were produced. Right, so if you know how to do this, if you know how to then deduce the empirical formula, I'm going to go ahead, pause the video and have a go with it. So you have a chance to have a go with it. Okay, so the next thing is, okay, in this one, we're given a reaction, copper reacting with nitrogen. So I'm going to begin this one by writing down what's going on. So copper reacted with nitrogen, so plus nitrogen, react to give copper nitride. What we want to do is deduce the formula of this copper nitride. Right, so underneath each one, write down the mass that we know from the question. I'll go back here, pause the video, write down the masses that we know. Okay, so what we know is that we have 19.05 grams of the copper, and we know that we produced 20.45 grams of the copper nitride. So the one thing we're missing is what was the mass of the nitrogen used. Now, you should be, if you haven't already, you should know how to work this out. If we reacted this with this to give this much of this, how much nitrogen was used? Pause the video and write down the answer. Okay, so hopefully you're realizing that what you're going to do is take this number and take away this number, and you'll get the rest of it has to be nitrogen. So copper, the rest has to be nitrogen to make this. So what we're going to get is 1.4 grams. That's what we should have got of nitrogen. So now that we have that clarified, we want to know what's the ratio of copper to nitrogen, Cu to N. Okay, so we begin. Okay, hopefully again, another chance to pause the video and find the empirical formula. Some of you may be able to do this by yourselves by now. Pause the video and do it if you can. You have to be having a go, guys. No point watching me do it. All right, the first thing we want to write down is the mass of each one, and then we want to convert to moles of each one. So again, another chance to pause the video. I'm trying to get you to do as much of it as you can by yourselves. Okay, and if you didn't know how to do that, you'll also need the MR of each of these things. You should definitely be able to do it now. All right, so what you should have so far is, well, we had 19.05 grams of copper for every 1.4 grams of nitrogen. The MR of these two things, MR of copper is 63.5 from your periodic table, MR of nitrogen is 14. So what we want to do to get moles is divide the mass by the MR. And when you do that, you're going to get this number comes out to be 0.3 is to 0.1. Then we get the ratio, just like we did before. How do we get the ratio? Pause the video, get the ratio. You divide by the smallest, remember? Again, if you didn't know how to do this, pause the video, do it now. You have to be building those skills. Okay, so what the smallest of these numbers is obviously this one, 0.1. So divide that by 0.1, and then you're going to divide this by 0.1. Put those in your calculator. What you should get here is you should get 3 is to 1. And your empirical formula then, write down your empirical formula and box it. Okay, so what this is saying is you have 3 coppers for every 1 nitrogen. So it should be Cu3N. And you box it like that. That's your final answer. Okay, all right, guys, that's that one done. Let's take a look at the next one. All right, next one's pretty straightforward. It's like the first one. Find the empirical formula for a compound containing 40%, so you give them percentage, sulfur and 60% oxygen by mass. Again, I'm not much help here at all. Pause the video and do this. You should be able to do this now. Right, so to show you how it's done, copper is to no, it's not copper, so sorry, it's sulfur. S is to O. We want to know what's the ratio of these things. Okay, that's the first thing you got to do. Then we're going to do, okay, write down the percentage and find the moles. Again, if you didn't do this already, pause the video, do it now. Sorry, guys, I'm saying that a lot, but again, I'm trying to hand the baton to you. I'm supporting you by giving you guidance, but you have to be doing the work. Otherwise, you're not going to learn anything here. All right, so what you should have done is filled in that it's 40% sulfur to 60% oxygen. The MOs then for sulfur is 32 and MO for oxygen is 16. Divide by each to get the moles, and you're going to get 1.25 moles of sulfur is to 3.75 moles of the oxygen. You should definitely be able to finish this out down to empirical formula. Find the ratio first, then the empirical formula. Do that now. Okay, so to get the ratio, the rule is you divide by the smallest. So in green, the smallest is 1.25. So divide that by 1.25, divide that by 1.25. And what you're going to get 1 is to 3. So empirical form, write it down, box it. 1s to every 3 O's. That's empirical formula, SO3. Next one, A bit like the second one, this one, but this one is a little bit tricky, so maybe I'll help you with this one. It says when hydrogen gas was passed over 1.59 grams of copper oxide, so think about what elements are going to be in that. So think in your mind now what elements are in copper oxide. Okay, so hopefully you see that there's Cu and there's O, copper oxide. 1.27 grams of metallic copper were produced. Now, of course, what else must be produced? If you're producing metallic copper, you also got to produce oxygen. Hopefully you're going to see that now in a second. I'll begin by helping you write that down. You've got copper oxide, and if it reacts with hydrogen, it produces, so we'll say hydrogen if you want, hydrogen plus copper oxide. The hydrogen is kind of just a byproduct here. It's not really that important. What's important is that you produce copper, but you also produce oxygen because that's what's in the original substance. And we're asked to deduce the formula of the copper oxide. So we need to know how much of it is copper, how much of it is oxygen. So the next thing you got to do is write down the masses that we know from the question. Pause the video and write down the masses now underneath. Okay, so if you needed to, sorry, you can take down this equation, then write down the masses underneath now. Okay, right, so it said copper oxide was 1.59 grams. It said we produced 1.27 grams of pure copper. So how much oxygen was left? Ignore the hydrogen, that's just helping the reaction happen if you like, but it's not part of, there's no hydrogen in this thing. This thing is breaking down to give this and this. So we know that 1.275 grams of this is copper. How much is oxygen then? All right, so hopefully pretty straightforwardly, you took 1.59, took away 1.27, and you figured out that 0.22 grams of this stuff is oxygen. The rest of it's pretty easy after that. So we've got the masses, find the empirical formula. Go and do that now. Everybody should be having a go at this one now. You should not be waiting for me to do it. You've done enough that you should be able to do this now. Write down the, okay, so we want to know what's the empirical formula. So we're talking about this substance, so we want to know what's the ratio of copper to oxygen. Okay, so the first thing you know is write down the mass, find the moles, what's in the middle, MO, then find the ratio, and then find the empirical formula. Again, this is the last bit of help you should need. Should definitely be able to do this now. Okay, so the mass of copper in this case we found out was 1.27. So 1.27 grams of copper is to 0.22 grams of oxygen. The MO, copper is 63.5 and oxygen is 16. Go ahead and divide them to get the moles, and you're going to get 0.02. So 0.02 moles of copper, and this one, when you do it out, you're going to get 0.02. No real need to divide by the smallest number there. They're both the same number, so pretty straightforward. The ratio is 1:1. All right, so once you do that, then you should get empirical formula of Cu. Oh, 1 Cu, 1 O. There's your empirical formula. Right, last one. We're flying through these now. Good stuff. It says when 3.175 grams of copper, so we've got an equation again. I'm going to start by writing out the equation. 3.175 grams of copper reacts with chlorine gas. We produce this much of copper chloride. So we're going to begin. I'm going to get you to start by writing down the reaction of what's going on here. So pause the video, write down the reaction. Just using words, a word equation. Okay, pause the video and do this. I did one of these earlier. Okay, so hopefully you can see that you've got copper plus chlorine react to give copper chloride. Right, next thing to do is figure out the masses of each. You know the masses of two, you've got to find the mass of the other one. It's pretty straightforward, same as before. Pause the video, do it now. Okay, so we're told that 3.175 grams of copper reacted with chlorine, that it doesn't tell us how much, so we're going to be finding that, and we produce 6.725 grams of copper chloride. If you haven't already, pause the video and work out what was the mass of chlorine used. Okay, so the mass of chlorine was, when you do this, you take this one and take away this one from it, you're going to get 3.55 grams of chlorine. So 3.175 grams of copper with 3.55 grams of chlorine gives you 6.725 grams of copper chloride. All right, the next step then is we want to deduce the empirical formula of this thing, copper chloride. So what we want to know is what's the ratio of copper to chlorine. Pause the video and find the empirical formula. Okay, so we start by writing down the mass. We know the mass, and we got to find the moles. And what do we need in between to find out? We need the MR. Then we need the ratio, and from the ratio, we write down the empirical formula. If you needed that bit of help, you really shouldn't by now. Pause the video, please finish this off. Have to have a go at this by yourself. Okay, next one is to write down the masses of each one. We were told we have 3.175 grams of the copper is to react with, and this is what we calculate up here. The chlorine was 3.55 grams. The MR of each one, well, copper is 63.5. We've seen that a lot in these questions. Copper seems to come up a lot, 63.5. And chlorine is 35.5. Put them in the calculator, find the moles. What we get is 0.05 moles of copper is to 0.1 moles of chlorine. Find the simplest whole number ratio. Pause the video, do that now if you haven't done it already. How do we do it? Divide by the smallest. Some of you may be able to just eyeball this, but always a good idea just to check anyway. The smallest of these two numbers is the 0.05. Divide both numbers by the smallest, and you're going to get the simple ratio of 1:2. So that gives us our empirical formula of 1 copper, Cu, to 2 chlorines, Cl2. That's your empirical formula. All right, guys, that's empirical formulas practiced in great detail. I would say come back to this video fairly regularly and go through them again just to remind yourself, because as you see, it's a pretty, it's a pretty common type of question. Yeah, that's it, guys. See you in the next one.